Okay, so in this video we're going to take a look at eliminating the parameter, right? So let's say that we had a set of parametric equations, right? X of t equals to 2t squared minus 6, and then y of t will be equal to 5 minus t. All right. Okay, so the purpose here, or the technique here we're going to be using is we're going to solve for t in one of the equations, x or y. It doesn't matter which one. Usually the one that's the easiest would be my advice here. And then now once you have something in t in terms of x or y, then you plug it into the other one, right? Now, looking at this, for example, I'll have my x of t and y of t. And I think what's going to be, for myself here, I look at the y of t equals 5 minus t. I think that's the easiest one to simply solve for t. So I'll take that, right? I'll write it as y, right? And just drop the y of t, implicitly defined as y of t. And then just here, essentially, I'll subtract y from both sides and add t to both sides. So this goes to 0, and we get t equals to, that's 0, we get 5 minus y. All right, so now I'll take this and go to my other parametric equation, and now we get x is equal to 2, and here t gets replaced by 5 minus y squared minus 6. Oops, the square is on the outside there. All right, and then we can distribute here, simplify, we get x equals to 2 plus 5 squared 25 minus 10y plus y squared minus 6. And then this turns out to be 2y squared, distributing the 2, minus 20y plus 50 minus 6. So you get x equals to 2y squared minus 20y, and then 50 minus 6 is a 44, plus 44. All right, and now we have eliminated the parameter. Okay, and that is my equation in terms of x and y. All right, so when eliminating the parameter, make sure that your equation that you end up with does not have any t's, right? If it has a t, that means you have not eliminated the parameter. All right. Let's take a look here. How about one more example here? Let's see. How about this example here? So here we have, let's say, x of t. That's equal to t squared. And y of t. That's going to be equal to natural log of t, where t greater than 0. All right. So again, here we're looking for a way to solve for t. So I think here we can, t must be greater than 0. So one way we can do this is, so let me try two different, let's say here. So we get x equals to t squared, and I can take the square root of both sides, and we get t equals to plus or minus root of x. All right, we're here, we'll make the distinction x must be greater than 0. Now if we want to plug it into y, here we have, okay, so y of t, or y, ln of t, since t must be greater than 0, I'll choose the positive. So we get ln square root of x. Okay. All right. And so that's one approach to do this. And actually there is, let's say you wanted to go the other route, right? You saw that and you notice maybe that you want to solve for t in the y, right? So you have y is equal to ln of t. All right, and then here, right, we can recall the definition of the natural log. This is true. That means that e to the y is equal to t. All right, so that's the definition of our logarithm, natural logarithm, but really any logarithm. All right, the result is some exponent. And now I can just plug this in for t. So x is equal to e to the y, this is t squared. So x is equal to e to the 2y. All right. And that is another way to do this. Okay, which actually is equivalent, right? Although they may look completely different, those two are actually they represent the same relation, same graph. All right.